All right, here's an example on graphing a rational function that has a slant asymptote. So step one is we're going to go ahead and see if there is some symmetry. Simplify it, we get x squared plus 4x minus 5 over negative x minus 3. We're going to go ahead and take out a negative 1. And we do not have symmetry. We don't get our original function back or our original function with a negative out in front. We're going to find the y-intercept. We're going to evaluate the function for 0. We get negative 5 divided by negative 3, which is 5/3. So as an ordered pair, it's over 0, up 5/3, which is pretty close to 2. So it's easier to graph when you change that to a fraction. So 1 2/3. To find the x-intercepts, we're going to set that numerator equal to 0 and solve for x. So we're going to factor it. What are the factors of negative 5 that add to negative 4? And that's negative 5 and positive 1. We use our zero product property. We set those factors equal to 0, and we solve them for x. So we add 5, and we subtract 1. So our x-intercepts are at 5, 0, and negative 1, 0. Next step is vertical asymptote. You set the denominator equal to 0, and you solve it for x, and you get x equals 3. That is also where we have our domain restriction. Number 5 is to find the horizontal asymptote. The degree of the numerator is 2. The degree of the denominator is 1. So we have this situation, that the numerator is greater than the denominator. Now here's what's important in the red. If your degree in the numerator is exactly 1 more than the denominator, then what we do is we use long division, ignore the remainder, and your equation will be in y equals mx plus b. If there is a slant asymptote, then there's no horizontal, so we have a slant. So we're going to use long division. So I'm just going to erase this here. The degree of the numerator was 2 and the denominator was 1, so it's 1 higher. So we're going to do long division. So what goes underneath the division symbol is your numerator. What goes out in front is your denominator, and you're ready to do long division. So we're going to take x and divide it into x squared. So what's x squared divided by x? X. If you remember, what happens is you're going to multiply that x to x in the front, and then x to negative 3, negative 3x. Put a line underneath it, and now we subtract, so we have to change those signs. All right, so now x squared minus x is 0. Negative 4x plus 3x is negative x. We bring down the next term and are ready to divide again. So x divided into negative x, or what is negative x divided by x? negative 1. All right, we're going to multiply again. Negative 1 times x is negative x. Negative 1 times negative 3 is positive 3. All right, be careful on this one now. We have to change the signs or subtract all the way through. So that's going to become an addition symbol, and this is going to become a subtraction symbol. So that is negative 8. All right, so now here's what it says. Our equation for our slant should be in y equals mx plus b. So this is going to turn it into an equation. Y equals x minus 1. Our slope is going to be 1, and our y-intercept is going to be 0, negative 1. All right, so I'm going to skip 6 for now and move on to graphing it. Okay, we had an y-intercept of over 1 up 2/3, and then x-intercepts of 5 and negative 1. So here's about where that y-intercept would be, and then x-intercept of 5, 0, x-intercept of negative 1, 0. Then we had that vertical asymptote. At x equals 3. Our slant was at y equals x minus 1. So we're going to graph the slope and the y-intercept. So our y-intercept is negative 1. Our slope is 1. So there's our slant asymptote. All right. We go back. If we look at these ordered pairs here, we're going to go along that vertical asymptote and along that slant asymptote. Over here we have this ordered pair. It's going to go up to that slant asymptote and down to that vertical asymptote. You can find some additional points if you want to evaluate the function around those asymptotes like we've done in previous examples.